Geometry video. Starting off, we're doing separation of variables. You did this in 5.2 when you had dy over dx and it equaled whatever, and you had to move, or dt, and you move the dt over in the y. That's all you're doing in separation of variables. Same thing. This just takes it to a little bit more of an extent. So obviously you can use it when you have x and y terms and they're on different sides of the equation. You want to get them to one side. You want to get all the y's to one side and the x's to one side. So you can see we start off with dy dx equals 5xy. We start off by getting the y over there, which is how it got there, by dividing by y. And then we want the dx over there by multiplying by dx. Now we have all the y's over one side, all the x's over the other. Now in your video, your book did a lot of crazy examples, and I put those on there. I'm not going to go over all of them because I think you guys are good with what you got in 5.2, and it's going to make for a really long video if I do. So, but I do have some examples that I want you to do that are not on your notes, that more so illustrate kind of the ease of this. So this is not on your notes, so you have to write this down. So now I want the general solution. So when I notice that I have y, x, dy, dx, x, I want to get x's on one side, y's on the other. So the first thing I'm going to do is multiply by dx, both sides by dx, which leaves me with f. Now I want to get it all. I still want all my x's over there, so I want y dy left over there. I want all my dy's over there. Then I'm going to have secant x over cosine x dx. So now I want to integrate. So when I integrate that, that becomes y squared over 2. And when I look at that, I don't have secant as a derivative of cosine. Cosine is the derivative of secant. None of them are integrals of each other. So what am I going to do? Well, before I integrate, I'm going to rewrite that. Secant is 1 over cosine. So now I got to say, okay, cosine 1 over cosine over 1 turns into 1 cosine x squared. Just in case you don't see that, when I pull that up, it's 1 over cosine x times 1 over cosine x, which is where I get 1 over cosine x squared. And I'm going to integrate that. I already integrated left side. I haven't integrated the right side yet. All I've done is rewrite it. So now I get y squared over 2. And then this, well, this would be dx. Sorry, I forgot my dx. First of all, u would normally be x. So if u is x, then du is dx. So I'm good with 1 dx here. But then when I'm going to rewrite this to integrate this, I'm going to call it 1 over u squared, which means it's the integral of u to the negative 2, which gives me negative u to the negative 1 plus c. So when I rewrite that, I have y squared over 2 equals negative 1 over, and u is cosine x, plus c. And now I want it in y squared. I want to get rid of that fraction, so I'm going to multiply everything by 2. And that would be, sorry, this would be c1. And then once I multiply it by 2, it would turn into c. c1 is definite to that equation. Once I multiply it by 2, now I'm getting into it could be anywhere. So that's my general solution. And I've got 3 of them that aren't on your notes already that I want to go over with you because they're a little bit easier than the ones the book gave you. I want you to comprehend it more than I want you to do exactly what the book says. So, for number 2, you have an initial condition. Right there, it tells me before I even read it, that if I have an initial condition, I'm probably looking for a particular solution. So my equation is 3x squared y prime minus x equals 0. So I notice I got x's and y's in there, so I want to split them up. So first I start by adding x to both sides. Then I want just y, so I got y squared y prime equals x over 3x squared. And I'm even going to take that one step further because I know I'm going to be integrating. So I'm going to rewrite that as y squared times dy dx. Dy dx is the same as y prime. Now if I multiply both sides by dx, I get that. And notice I still haven't integrated yet. We know we're going to integrate because we're looking for a particular solution. But even still, I can still rewrite x over 3x squared. My x's cancel out. I'm left with 1 over 3x dx. So now I'm going to integrate. And I would get y cubed over 3 equals 1 over 3x. Well, that'd be u is 3x, so du is 3 dx. I want 1 dx, so I can divide that by 3. And then I'm left with 1/3 the integral of 1 over u du. Integral of 1 over u du, or u prime over u, another way to say that, is the natural log. So then I get y cubed, and I'm going to multiply both sides by 3, which will take out that, and when I multiply this by 3, and that would be c1. When I multiply that side by 3, those cancel out. 3 times c1 would turn it into c. So I have ln of 3x plus c. There is my general solution. Now I want a particular solution, and it tells me that y of 1 is 2. And a lot of people get tripped up by that. Think of y. Y is the same thing as f of x. So it'd be x is 1, y is 2. So it's 2 cubed equals, sorry. This whole thing would be 2 cubed ln of 3 times 1 plus c. Now, I would make that, you can say, well, this is y. Y is 2. And you say, well, if that's f of x, I mean this whole function would equal 2. And I agree with you on that, but the fact that we didn't solve this function for y. We solved it for y cubed. So if I took the cube root of both sides, it'd be the same thing. Then it would just be equals 2. But since I didn't take the cube root, I'm going to leave the cube over there and make it easier on myself. So that becomes 8 ln of 3 plus c. So now to solve for c, I would subtract ln of 3. And when I put that in my calculator, I get 6.9, rounding to the nearest tenth. So then I plug that in to my general equation, my general solution. So I get y cubed equals ln of 3x plus 6.9. And the last one I want to do, that isn't on your notes, find the equation of the curve that passes through that point, 3, 2, and has a slope of this. So, it has a slope of that, and they want it at any point. So, if it's a slope at any point, at any one point, so dy dx, remember, derivative is slope at any one point. I rewrite it like that. Now I want to separate my variables, so I multiply both sides by y cubed. Then multiply both sides by dx. Now I have my variables separated, so I'm going to integrate. So I get y to the fourth over 4 equal, and this will be negative 4 times x squared over 2, which will give me negative 2x squared plus c. Now I'm going to multiply each side by 4, which give me y to the fourth equals negative 8x, this will be c1 again, plus c, when I multiply the whole thing by 4. So now if that's my general solution, if my point is 3, 2, it means x is 3, y is 2. So y is 2, x is 3. So then I get 16 equals negative 72 plus c, which means c is 88. So when I plug c back in to get that equation, I get y to the fourth equals negative 8x squared plus 88. Now going back to the notes from the book, the notes that you already have, you can see that number 1 is kind of the same thing. The only difference with number 1 is you're going to end up with logs and e's in there you're going to have to use. And once again, your book runs through all this. So if you want to see it, look at your book. If you still don't understand it, ask me. Same thing with 2. Just e's in there now. 3 ends up using natural log and e's as well. And once again, doable. You do them the same way. I just didn't want to start you off with those and have your head spin. I thought the other ones were a little easier to do before we got into those. So you can look at your book for those. This is number 4. And I actually want to do number 6. 4, 5, and 6 are all pretty much the same thing. For number 6, you have a chemical reaction. Substance A is converted into B at a rate that's proportional to the square amount. That's T. T is 0, 60 grams of A are present. 1 hour, 10 grams are. How much of A? So that tells me, okay, it's kind of like half-life, but it's not a half-life. So I'm going to do dy dx equals kt, or dy dt, sorry, is kt. And then the square amount of A. Well, that tells me that dy dt is k times y squared. Remember, y, if you're looking at the half-life formula, y is how much you have left. So it's kind of the same thing in this. So how much I have left is y squared. So, and your book does really good on these two. For like number 6, it'll show you, and it'll show you all of them. It says, you know, dy dt is the rate of change, and then it's proportional. Remember, k is proportionality, and y is the square amount. So they specify each one of those on your book for you. They do a really good job of that. So now I'm going to separate my variables. So I'm going to multiply by dt and divide by y squared. Flip those over. So then now I have my equation, I can integrate. And I can say that'd be y to the negative 2, which would give me negative y to the negative 1. Negative y to the negative 1, which would give me negative 1 over y. That's dt, it's kt plus c. And then if I solve for y by multiplying by negative y and then dividing by kt plus c, I would get y equals negative 1 over kt plus c. Hopefully by now you can see that kt plus c is going to be along the lines of CE to the kt, to be somewhere in there. So now, when t is 0, in our word problem, t is 0, I have 60 grams, so y equals 60. So y is 60, k is 0, so this whole thing is 0. So I get 60 equals negative 1 over c. So when I move those around, I get c equals negative 1 over 60. Then I can take, when t is 1, y is 10, and once again, that's in the word problem. So now I can say, using my original equation of y equals negative 1 over kt plus c, I get 10 equals negative 1 over k times t, which is 1, which is just k, minus c we just solved for, which is 1 over 60. Maybe plus c, since c is negative, it's minus. So then once I solve that by multiplying and dividing, or multiplying and subtracting over, I'd get k equals negative 1/12. So now that I have c and I have k, I can go back to my equation and plug those in. K is negative 1/12. C is negative 1 over 60. And they want how much of A is left after 2 hours. So I'd say y equals negative 1 over negative 1/12 times 2 minus 1 over 60. And I could simplify this whole thing first, or I could just plug that in. Either way, you're going to get 5.45 grams left. And once again, you did this. When you solved for C, when you did the KTs on the exponential growth and decay, you separated your variables. So this shouldn't be that new. I just wanted you to see different ways to do it. Number 7, don't worry about that. I meant to take it off and I forgot. Gompertz. We're not doing Gompertz, so don't worry about Gompertz. You don't need to know that for the AP test. Definitely don't worry about 7. But any of the word problems, if you want me to go over them in class with you, I will. So just ask me. But I figured that would make a really long video if you didn't need to go through all that. I just wanted to cover the basics. Questions? Let me know.